Hi, I'm Alix Paultre with AspenCore, and I've got my good friend Kevin Speer here from Littelfuse. And well, we're at the Wide-Bandgap Power Conference here, and obviously Wide-Bandgap is on everybody's lips. But are we done talking about Wide-Bandgap yet, or are people finally seeing it, or is there still an educational mission out there?
Yeah, and thanks for having me, Alex.
Please, the pleasure's mine.
It's a good question, and it's one that I think we've seen to be a very dynamic and evolutionary process over just the last couple of years. The silicon carbide Schottky diode has been out since 2001, so that's kind of a given. It's a proven technology. But the MOSFET, the power switch, this is what everyone is looking to displace potentially the pervasive silicon IGBT. So I think what we've seen is an inflection point in the warmth with which the customer base is adopting this emerging technology. People are now looking at it as something serious that they're looking at new projects and new products that they anticipate releasing, whereas a couple of years ago it was just, let's just see what this can do in the lab.
Make some nice toys and who's going to buy them?
Exactly.
Well, it's come up before and it's a word beaten to death, but it has to be a solution. It can't just be a part anymore.
Exactly, and that's the key message that Littelfuse intends to deliver at this event. Is one thing that I believe has been lacking so far with the promotion of silicon carbide into the market is it's been sort of a let's pitch this over the fence approach, pat ourselves on the back for making a disruptive technology and let them figure out how to use it. Littelfuse has a different approach. We are making the device. But we also understand that if there are design barriers and hurdles that the customer must overcome in the process, it's our responsibility to help those customers overcome them.
Agreed, Kevin. Well, if you think about that aspect, for example, industrial. The industrial space is under so many different disruptive pressures. Automation, artificial intelligence, just better system management. Better software, all of those things. But the other side of that coin is, no matter how sophisticated the facility is, if the infrastructure's not there, you're floating on ice.
Yeah, and I think one macro trend, if you will, along with automation is energy efficiency. And wide bandgap, that's the big hype behind wide bandgap and silicon carbide is how can I improve the infrastructural efficiency? And silicon carbide can do that if the system is optimized, and that's what Littelfuse brings to the table.
Well, exactly, because when you start thinking about a modern power solution for, say, an advanced facility or a small campus, it's going to have its own microgrid, it should be integrating alternate energy, it should have storage on site, it should have all the trappings of smart grid.
Sure.
But there's a lot of, jumps over hurdles between getting from, let's make a facility and having that facility. So obviously they've got to come to solution providers like you and get that support. It's one thing to buy a part, but what about the support to dial it in?
Yeah, it's a good point that you make. With big, with microgrids, with distributed generation of power, it's not all coming from the typical utility companies. Now it's coming from renewable sources such as wind and solar. There are a lot of I's that need to be dotted and T's that need to be crossed with this. So Littelfuse, as you've seen with our announcement of the partnership with IXYS, we are trying to expand and deepen the breadth of our overall power control portfolio so that we can offer complete solutions to our customers. At the end, Littelfuse is very customer driven.
Well, that also means you have to have a good FAE support staff out there because people need that hands-on help.
Yeah, it's one thing to talk about it, right? It's another thing to deliver it. And we have a very strong, skilled roster of FAEs that are prepared to support with all of this very critical optimization of systems that silicon carbide requires.
Now, are there some specific product families? Are you doing customization for your clients as well? Or is it you've got your off-the-shelf parts and then you help them optimize it for their application space?
So we're getting ramped up with our product offering. We just released our first 1200 volt silicon carbide MOSFET a couple of months ago. And we intend over the coming months to expand that portfolio substantially. For the time being, it's going to be discrete product portfolio. We believe that there is still some pretty big leaps that need to be made in terms of optimizing the multi-chip power module package. So in the near term, we're going to be releasing and expanding our existing portfolio of discrete silicon carbide products. We've got silicon carbide diodes. We'll be expanding that family, and the same goes for the silicon carbide MOSFETs.
Excellent. Now, Kevin, one of the other points that I like bringing up when I talk wide bandgap is packaging. You know, I think we're all tired of seeing, you know, someone putting a silicon carbide product in a TO220 package, but everybody seems to want that TO220 package. What about the packaging?
Yeah, the silicon carbide device community is sort of caught between a rock and a hard place. What I mean by that is we're asking design engineers to incorporate a disruptive technology that presents new challenges like we've just talked about. So it's one thing to get them to say, okay, I'll accept that challenge and deal with it. But when you give them a product that looks like something they've never seen before, that makes it a little bit more daunting. So as a device maker, we're trying to walk that fine line and help them optimize a solution, but not give them something that looks like an alien from outer space. There is going to be a transition in the packaging community and packaging technology in general that will migrate to allowing users to leverage wide bandgap devices to the best that they can be. But I think it might be a little bit too much for asking a customer to bite off than they can chew and giving them everything new.
And they have to jiggle their topologies and everything.
Right. Change topologies, change gate drivers, optimize the parasitic inductance of all these different components. Then you're asking them to look at a different package. It's a lot to bite off. But I think that's, like I said, we're caught between a rock and a hard place. And I think for the time being, it remains wise, it remains prudent to offer these disruptive technologies in a conventional package. And we'll all kind of keep our eye on the prize at making a really revolutionary package to go along with the revolutionary die technology.
So Kevin, before I let you go, do you have any final tips or advice or any information for our audience?
Absolutely. I think what's really critical and associated with this event for wide bandgap semiconductors is people realize that it's a very complex and sophisticated technology, but the design-in process doesn't have to be. And that's what Littelfuse and our application engineering resources are here to do is help with that, help overcome those barriers.
And that's what it's about, right? Solving problems, making cool products.
Exactly.
Thanks, Kevin. I appreciate you taking the time to be here.
My pleasure.